Hello everybody, so today you're going to learn physics. I promise. Force vectors and friction. That's what you're going to learn today. So there are two different kinds of friction. There is static friction, which basically means that the object is not moving, and it's the force of friction while it's not moving. I guess that's the best way I can explain it. If you push on an object and it doesn't move, the reason for that is static friction, because in a perfect world without friction, you push something, it'll move. And that's the way it is. And the other kind of friction is kinetic friction. And if you've taken Ms. Shelnick's class, you know that kinetic friction is motion. So it's the force of friction while an object is moving. That's all it is. So there's another thing called mu. Mu looks like this. Looks like a wonky M. It's the coefficient of friction, and on a graph, if here you had the force of friction right there, and then you had the normal force, and the normal force is just the perpendicular to whatever surface the object is on. If it's on a table and it's horizontal, then the normal force goes perpendicular to it. And if that table is tilted, the normal force is also tilted. But when the table is horizontal, the normal force is equal to gravity, so it just cancels out. No biggie. So on this graph, we have our line. And that line is mu. So if you looked at this in, say, a formula way, then it would be the force friction divided by, because that's your y, basically, divided by the normal force, which is your x. So that's basically y over x, or rise over run. This is just slope. That's all that this is. That equals mu. And then you can change that into a bunch of different things, like the force of friction is equal to mu times the normal force, or the normal force is equal to whatever. You can manipulate the formula in any way that you want to. But two things that you need to know: the force of friction static has a greater than or equal to sign right there. And I know that confuses people, but basically all that means is, say it takes 1 Newton of friction to keep my laptop here from moving when I push it. Well, if I push with 1 Newton, then my laptop's going to move. But if I push with 1,000,000 newtons, my laptop will also move. So it basically means anything 1 Newton and up will move this laptop. However, if it's 0.9999 newtons, this laptop won't move. That's all that it is. It's a force that has to be broken. And that's all it means. So let's do a quick problem. Let's say that there is a table. And on this table is a box. This box weighs 1 kilogram. And we're going to push it horizontally with a force of 30 newtons. So that's its force, 30 newtons. And that's all we know. What we want to know, well, no, we also know the mu. Mu is equal to 0.3. And let's not worry about significant digits, just for our purposes. But what we want to know is the acceleration of this box. So what do we know? Well, if we apply gravity, we know that the force of gravity equals the mass, which we have, times the acceleration, which we know is 9.8. But for our purposes, let's just say it's 10. It'll be easier. So we'll say that this has 10 newtons going down. Well, that makes it negative since it's going down. We'll say that up, well, if we're going to say that that's negative, this is also negative. just because it's going to the left, and that makes everything easier. Well, if it's going up with 10 newtons, because it's not accelerating up or down. That's all you need to know, and that's how you know that the bottom is equal to the top. So what we want to know is the force of friction here. Well, we know that the force of friction equals the normal force times mu, which we have both of them. So 10 times 0.3 will just equal 3. So we know that the force of friction back is 3. We know that F net equals all the forces combined, so negative 30 plus 3 equals 27. So the net force here is 27, negative 27. But the negative, all that it means is the direction. It won't change the number. So we know here that it's 27. Well, we know that the net force is 27. We know that F net equals the mass times, no, not divided, my bad. F net equals mass times acceleration. If we know the F net is 27, we know the mass is 1. We want to find A. So 1 just cancels out. We're left with 27 equals A. Now, you could do all the units and whatnot, but basically you know that it figures out. But if you wanted to, you know that F net is in newtons. And over here, mass is in kilograms. And that acceleration is meters per second And we know that a newton equals meters, kilogram, per second. So if you divide 27 by 1, you're going to multiply by 1 over kg. Because you can multiply and divide the units just like you can anything else. But if you see if it's this times this, the kgs will cancel, and you're left with meters over second squared. And that's what acceleration is. So yeah, that was basically all you need to know for friction. So I guess I'll see you guys in the next video if you feel like watching it. But that's all you need to know for friction. Promise.